Okay, guys, today we're going to talk about probability. This video should build on what you've already learned from the video that Mr. Euler presented, and it's also going to give you an opportunity to answer some questions. Let's take a look. What does probability mean? Well, probability of an event happening equals the number of ways it can happen divided by the total number of outcomes. So, number of ways it can happen. What that means is how many things can you get that you want to have happen versus how many total tries are there. So let's take a couple quick examples. Number of ways it can happen. If you're flipping a coin, you want to get heads. Well, there's only one way it can happen. Total number of outcomes, there's two sides on the coin. The probability of the event, which is getting a heads, would be 1 out of 2. All right, probability is measured on a scale from 0 to 1. You can see here things that are 0 or 0% are impossible. Those are things that cannot happen. They never happen. Things that always happen have a probability of 1 as a decimal or 100%. Those things are certain to happen or always happen. Things that are right in the middle happen 50% of the time or 0.5 or half the time. Those are called equally likely, sometimes called 50-50. Or even chances, or even as likely as not, all names for things that happen 1/2 of the time, or 50%. Now, everything above 1/2, but below 1, is considered likely because it happens more than half the time. Now, stuff that happens just barely more than 1/2 the time doesn't happen as often as things that happen just barely less than 100% of the time. But everything in this section is considered likely because it happens more than half the time, but less than always. Now, on the other side is from 1/2 down to 0, all these things are considered unlikely to happen. They don't happen 50% of the time, but they also happen more often than never. So all the stuff in this section is considered unlikely. Let's take a look at some examples. So, where would we put these on the scale? The day after Monday will be Tuesday. Well, that's something that always happens, so that would be considered certain. It'd be placed here. Getting heads when flipping a coin. Well, there's two sides on a coin, total number. One of them is heads, so it happens half the time, 50%. That's equally likely, or as likely as not. The same thing when you're getting tails. Again, there's two sides on a coin. One of those is tails, so it'd also be equally likely, 50-50. Now, rolling a 6 on a number cube. Just on one die, you roll one die. Those are numbered 1 through 6. So you have one chance out of 6. Well, that's less than one chance out of 4. So one chance out of 6 would be somewhere over here. And that would be not impossible, but unlikely. Rolling a number greater than 2 when rolling a number cube. Well, numbers greater than 2 include 3, 4, 5, and 6. So that would be 4 out of 6 chances. Or if you reduce that fraction 2/3, so that's more than 1 out of 2 chances, but less than 3 out of 4. So that would be 2/3 or 66.6%, somewhere in the likely range around here. And then finally, pulling a red marble from a bag containing only green marbles. Well, if there's only green, it's 0 reds or 0% chance. All right, let's take a couple questions here. On the probability scale, an impossible event is equivalent to what percent? Go ahead and answer that. Yeah, hopefully you realize that an impossible event can't happen at all, so that's 0% chance. Heads on a coin flip has a likelihood. Remember, when we ask about likelihood, we're looking for the words, not a number, not a percent, not a fraction, but the words. Answer this question. Yeah, hopefully you remember that heads on a coin it's not impossible. It doesn't happen every time. It doesn't happen more than 50%. It doesn't happen less than 50%. It actually happens exactly 50% as likely as not. All right, let's take a look at spinners. Spinners are, we see them all the time in games and all kinds of different stuff, but they're not always set up the same. Take a good look at this one. There are 8 total sections we can see. It's numbered nicely for us, 1 through 8. But how many are blue? Well, there are 3 blue out of 8 total. So the probability of landing on blue would be 3/8. How many are red? Well, there's only 1 red out of all 8. So the probability of landing on red would be 1/8. Now, what 2 colors have the same probability? Well, we see we have 2 yellow, 3 blue, 1 red, and 2 purple. So 2 out of 8 for purple, 2 out of 8 for yellow. If we reduce these fractions, these are both 1/4. So 1 out of 4 times we would expect to land on purple or yellow. So the 2 colors that have the same probability are purple and yellow. How many even numbers are on the spinner? Well, we can count those up. 2, 4, 6, and 8. That's 4 even numbers out of 8 total chances. 4 over 8 reduces to 1/2. Or if we wanted to say that as a percent, 50%, 0.5 as a decimal, and we could say it's as likely as not to get an even number on the spinner. All right, let's answer a couple questions about spinners using probability. What is the probability of landing on red? Go ahead and answer that question. You probably see here that you have 1, 2, 3, 4, 5, 6, 7, 8 total sections. 3 of them are red out of a total of 8. So the answer is 3/8. What's the probability of landing on a 4? Okay, this one doesn't have to do with color. Go ahead and answer this question. You can see that again, 8 sections, 2 of them are 4, so 2 out of 8, but I don't see a 2 out of 8. Oh, 2 out of 8 reduces to 1/4. Great. Marbles. Lots of probability stuff with randomly choosing a marble out of a bag. You have to pretend like you can't see the marbles and you're just reaching into that bag and picking them out without looking. So how many marbles are there in there total? We can count this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 total marbles. So what's the probability of choosing a red? Well, 1, 2, 3 chances to get red out of 10 total. So that's 3/10 as a fraction, 30% as a percent, or 0.3 as a decimal. Blue, we have 1, 2 blue marbles. So again, 2 out of 10. That actually can be reduced to 1/5 as a fraction, or 20%, or 0.2 as a decimal. A marble that's not green. Okay, well, how many marbles aren't green? 1, 2, 3, 4, 5, 6 marbles not green, not green. So that's 6 out of 10, or reduced fraction, 3/5. 6 out of 10 is 60%, or 0.6 as a decimal. And what's the probability of a yellow? Well, we can see 1 out of 10. That's a 10% chance. Oh, the last one, a green or a yellow. So we need to look at 1, 2, 3, 4 green plus 1 more yellow makes 5 out of 10. Well, 5 out of 10, I think everyone knows, is 1/2 or 50%. All right, let's answer a couple questions on this. What's the probability of selecting a red or green marble? Remember that example. How many total marbles are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 2, 3, 4, 5 red or green. That would be 5 out of 10, or 1/2, 0.5. What's the probability of selecting a red marble? Okay, well, we know we have 10 marbles. 1, 2, 3 are red. 3 out of 10 is 30%. How likely is it that you will select an orange marble? Look closely, don't let this one trick you. When there are no orange marbles, clearly it is impossible to select an orange marble. All right, let's take a look at die. Dice are used a lot. We're going to talk about one die, a single number cube. How many sides are on it? Well, on one die, there are 6 numbers, 6 sides. So what's the probability of rolling an even number? Well, the even numbers would be 2, 4, and 6. So that would be 3 even numbers out of 6 total, or a 1/2, 50% chance. Odd numbers would work the same way. 1, 3, and 5 are all odd, so that's 3 numbers out of 6, or a 50% chance. A 5 or a 3. So that would mean we can get a 5 or a 3, so that's 2 out of 6 numbers. That would reduce down to a 1/3 chance as a fraction, or a 33.3% chance. Remember that 1/3 is that repeating decimal, 0.3 repeating. And then finally, could we roll a 7? Well, if there's only 6 numbers and it only goes 1 through 6, could it be a 7? No, that's impossible. A 0% chance. All right, let's answer a couple questions using die. Take a look. The probability of rolling a number greater than 2. The numbers greater than 2 are 3, 4, 5, and 6. So if you were counting, that's 4 out of 6 chances. One of these fractions reduces, or 4 out of 6, I should say, reduces to one of these fractions, and it is 2/3. Last question, what's the probability of rolling a 2 or a 3? So we've got how many chances? That's right. We have 2 out of 6 chances. 2/6 reduces to 1/3.